So in the last two video lessons, we were looking at the end behaviors of a polynomial function graph. We need to figure out what happens in between those ends, and the x-intercepts will help us do that. Remember, whenever we find the x-intercepts of a polynomial function, the first thing we want to do is factor, and that's an important step. Factor the function and then solve for the f of x or y equals 0. So here's an example of a polynomial function, and you can see we've already factored this. So now all we need to do is let the equation equal 0. And we see that 3x could equal 0, x minus 1 could equal 0, and x plus 3 equals 0. This gives us 3 x-intercepts. If I substitute -3 into this factor, it gives me 0. If I substitute 1 into this factor, it gives me 0. If I substitute 0 into this factor, it would give me 0. Now pay attention here. I can write then that the p of 0 equals 0. Think about what that's saying. This is our x value. It says when x equals 0, then y will equal 0. The p of 1 equals 0. When x equals 1, y equals 0. The p of -3 equals 0. When x equals -3, y equals 0. So let's think about what we were just saying. If we have f of r equals 0, that's what I was just doing in that last bit of writing we said. Right, here's my p of r equals 0. Only r is 0 or 1 or -3. We found the x-intercepts. We could make these statements. So what do we need to understand here? If the f of r equals 0, then r is called a real 0 of the function. R is also an x-intercept on the graph of the function. X minus r will be a factor of our function, and r is a solution to the equation f of x equals 0. Take some time, go back to the example we just did, and then read these over until they make sense. So let's look at a couple of examples. We want a polynomial of degree 3 given these zeros. -3, 2, and 5. So if those are the zeros, we just said that x minus r is a factor if r is a real 0. X minus r. X minus -3. X minus 2. X minus 5. There's a polynomial function. It has a degree of 3. It has those real zeros. So what would be the end behaviors if a, remember we have some number that could multiply our function here? What if a is +1? Well, this has a degree of 3, which is odd. We have positive leading coefficient. We need to think about the graph of y equals x cubed. We know that the ends will fall on the left and rise on the right. What if our leading coefficient is a -1? Still an odd degree, but now a negative leading coefficient. We know the graph will rise on the left and fall on the right. Can you find, for question 2, two polynomials, f and g? They should both have a degree of 4, with the zeros -2, -1, and 3. Well, let's start with f of x. -2 is a 0, so x minus -2 is a factor. X minus -1 is a factor. X minus 3 is a factor. This only has a degree of 3, and we want a degree of 4. I guess I could let this one be squared. That means g of x is going to have the same factors, but I want it to be a different function, so I could let this one be squared. There was a third possibility. Any one of these three, or any two of these three, would have been a correct answer. Take some time to look at that. We'll work on these next questions in the next lesson.